Good morning, dear students. Welcome to another session of Introduction to Data Structures and Algorithms. So in previous session, we discussed regarding representation of multidimensional arrays in the memory. Then we were looking forward to represent the same using the program. So in this, two main discussions were pertaining to column major order and row major order. That is how the elements in the array are placed in the memory. So that is the concept what we observed in the previous case. And we solved a problem pertaining to what is the address when the row major order is followed and what is the address of the element when the column major order is followed. So these were the few aspects what we had discussed. So let us continue from where we had stopped yesterday. So next, what we'll be doing is we'll try to look out for a program in which you just try to realize a 3 by 3 matrix. So in what is the case is since you are dealing with multidimensional, and in this case, since it is a 3 by 3, so we have two dimensions which are present over here. So this is a two-dimensional matrix. So how do we define a two-dimensional matrix? We specify how many rows are there and how many columns are there within the square brackets as it is represented over here. So in this case, M is the name of the array, and this array is having 3 rows and 3 columns, and it is storing what kind of data? It will be storing integer data types. It will be storing integer data types. So next, what here they are doing is they are asking the user to enter the elements of the matrix. So in this case, what happens is since you have two indices, that is two subscripts which are present. So based on these, we have to analyze the entries. So again, I just specify if it is a 3 by 3 matrix, say if I have the row index, the index will start with 0, 1, and 2. So this indicates that there are 3 rows. The first row index is 0, second row index is 1, third row index is 2. So similarly, column is specified over here, in which the first column is identified by the index 0, second column by 1, and third column by 2. So here, suppose if I want to say identify what is the index of the element which is present at this point. So it will be given by 0th row, 0th column. So if I write something like this, 0 and 1, that is in the statement somewhere. 0, 0. So this tells that it is this element what you are referring to. So if some other this thing you want to observe, say row 1 and column 2. So this will be specified as M of 1 and 2. So that is row 1 column 2 element which will be falling over here. So this will give you that element which is present in row 1 and column 2. So referring to that part, how do we read the elements? So here we have two for loops. One for loop which is say referred for the row information. Say I'll consider say this as the row, and another for loop which will be helping us to traverse through the column. So here index I which is there, it is used to identify the row, and index j is used to identify the column. So now in this case, so again we can observe over here. So we have a for loop. So first I is equal to 1 is executed, then whether it is checked whether I is less than 3. Now here you can observe this condition. What are the possible values of the indexes? It will be 0, 1, and 2. So here when you're writing the logic, you should keep these indexes in mind. What is the maximum value of I? That is the, since 3 rows are there, it can reach maximum up to 2. So this condition is helping identify that. If you write I less than 3, this for loop will be executed for I is equal to 0, and since increment is there, it will be I equal to 1 and I equal to 2. When I becomes 3, it comes out of the loop. Instead of writing this condition in some this thing, you can just change the logic as I lesser equal to 2. So this also does the same operation. So this will help the for loop to execute for I is equal to 0, I is equal to 1, and I is equal to 2. When I is equal to 3, the condition fails. So this also fails and this also fails. So invariably, you can see that these changes might be there in few of the cases. So first, the zeroth row element is considered. It checks whether it is less than the number of rows which is permitted over here. So if these two are satisfied, if initialization is done only once, if condition is satisfied, it enters this for loop. So here you can see that this for loop is not having any parenthesis. It is not having any flower brackets. So what does this imply? This implies that this for is having only one statement. So this part which is there belongs to the for loop, belongs to the for loop, that is this outer for loop. So next, what is done? You go for the next for loop. So here you are initializing j is equal to 0. Again, you're checking whether the number of columns. So this is referred for columns. This is referred for rows, whether the number of columns is less than the permitted value. So if yes, you execute this part. So this is actually part of the second for loop. This entire thing is the part of the second for loop. So here j is equal to 0, j less than 3. So here what they are doing is they are asking for each of the elements. So in the initial state, what it was, it is I is 0, j is 0. So it will be m of 0, 0. That is the first element. That is the first element what you are seeking for. So you ask the user to enter that information, and that information is stored in m of 0, 0. It is stored in m of 0, 0. So now what happens is, since you are in this for loop, j gets incremented. J gets incremented. Unless and until this condition fails, it will not go and increment I. So for this for loop has to complete its execution. So now j gets incremented. What is the value of j? J will be 1. So here what happens? The next element. So this is 0th row, first column, 0th row, 0th column, first column, and second column. So now this element you are entering. This element you are entering. So that element is accessed. So in the similar way, what happens now? J will be 2. J will be 2. Condition is still satisfied. So third element of the 0th row is entered, is taken from the user. So now what happens? J will be 3. But what is the condition? Is 3 lesser than 3? False. So therefore, it comes out of the loop. So but here still we are in the above for loop. So I was 0. So now I gets incremented. It will become 1. It will become 1. So 1 is still less than 3. So again, this condition is satisfied. Therefore, what happens? This for loops starts to execute. And in this process, again, j is initialized in the starting step, and then the condition is checked, and then the steps are repeated. So this will be repeated until you take all the elements from the user. So this is how you accept the data from the user for the two-dimensional array, and you use the traverse function to print the elements which are present in the array. So that is what they have done in this case. So by traversing through the elements of the array, you are printing it. So this is what is being done in this case. So what we'll try is, Okay, so this is the function what we are looking for. Sorry, yeah, this is the program what we are looking for, in which we are trying to realize a 3 by 3 matrix, which is a two-dimensional matrix. So what we'll do is we'll try to see what are the elements which get added. So M will have a track, I and J will have a track. So okay, these elements we'll try to keep a track over here. So now I'll perform the step-by-step execution so that you can observe what changes are happening with respect to the indexes. Okay. Okay. So now M is being declared. Here you can see that there are garbage values. You can see how the data is being stored. So you are declaring 3 rows, 3 columns. So here you can observe this is referring to the 0th column. Sorry, 0th row. This is referring to the say I'm referring to the index. So row with index 0 is present over here, row with the index 1 is present over here, row with index 2 is present over here. And you can see that there are three elements in each row. So this is referring to that there are three columns which are present in each of the rows. So therefore this matrix is 3 by 3. So this is these values what they are displayed is, it is all the garbage values. And here depending on the whether the column order is followed or row order is followed, address of these elements will be altered. Okay, if column wise they are stored, then that address will be different, that is column major order. If row wise they are stored, they follow the row major order. So that you can try it out by printing the addresses and try to see whether it is following column order or whether it is following the row order. So in this case, what we are doing, so we can observe the values of I and J. So I is initialized to 0. I is initialized to 0. So the next statement which falls within the this for loop, which is associated with the I, is only this statement, only the for loop. So therefore, in the first this thing, I gets initialized to, J gets initialized to 0. Now J is less than 3. So therefore condition is satisfied. It enters the for loop. And what it is specifying, it is asking the user to enter the information which is pertaining to M of 0, 0. So here, when we go to scanf, so it is asking to enter this information. So now here what we'll do is we'll enter the data in simple this thing. Say 1 has been considered. So here you can see that 1 is being replaced at that point. And when this execution completes, J gets incremented. J gets incremented. Now J is 1 and 1 is less than 3. So condition is still satisfied. So it goes and accepts the next element. So who is which is identified by M of 0th row first column. So 0th row first column. So it is asking for 0th row first column. So I'll just enter it as 2. So you can observe 0th row 0th column element is 1. Here element is 2. So now you can observe that J is equal to 2. It is incremented, condition is checked, satisfied. Therefore it enters the loop. Therefore what we have, we will be entering now 0th row second column. 0th row second column. So 3. So 1, 2, 3, these are the elements which are present at those specific indexes. So now you can observe J is equal to 3. So 3 less than 3 condition fails. Condition fails. So therefore what happens? It goes to the for loop. And in the for loop, what happens is I gets incremented. Now you can see what is the value of I. So previously I was equal to 0 and this for loop got executed. The condition failed. So it went and incremented I. So I became 1 now. 1 is less than 3. Yes, the condition is true. The condition is true. So therefore, what happens is we continue with our execution. Now you can observe what is the value of j. Again, this is the new for loop which will be executed. So which will be executed for the first time in the next iteration. So therefore, j gets initialized. So j will be initialized to 0, condition is checked, and you accept the information. So this process will be continued till you enter the other informations. So I have entered directly those information. So I have entered directly. So these elements come into the array. So now you try to print what all elements are present. So it is naturally observed here itself. So these are the elements which are present in the array. So we traverse through the array elements. And again, what we do is we use row index and the column index to traverse through the array elements and print it. The logic will be same. So now we can see that these are the elements which are printed, which are present in the array elements. Okay. So this is what is happening in case of the how we realize the 3 by 3 matrix, a 3 by 3 array matrix, that is 2-dimensional array matrix. So this is the program pertaining to this. So what are the operations which we can perform on the multidimensional arrays? So we'll be considering the 2-dimensional aspect. So what are the different operations which we can perform on the matrices? So it is the conditions you should be knowing that when you're adding two matrices, the rows and columns, they should be matching. When you're multiplying, the column of one should match with the row of the other, then only multiplication is possible. So those all conditions, we assume that you know those. So in continuation with those, what we'll try to do is what happens in addition, subtraction, multiplication, and transpose. This is what we'll be looking forward. So when we are adding two elements, so let us consider matrix A and matrix B with the elements specified as A1, A2 up to A9 for matrix A, and similarly B1, B2 up to B9 for matrix B. So it is like in a normal case, this is your first row, second row, third row, first column, second column, third column. When you're referring to the indexes, index will be 0, 1, 2, and column will be 0, 1, 2. So similarly, even for B also you have the same case. So when you're adding two matrices, right, their rows and columns should be equal. Number of rows and number of columns of both should be same. So when we add these two elements, how the addition goes on, you take the first row and first column element of matrix A and add with first row and first column of matrix B. That is, you want to perform addition. So it will be A1 plus B1. So element by element. So present in its specific row and specific column. If an element is present in row R and column C of matrix A, then I have to add the element of B which is having the same index R and C. So it is having the row index value as R and column index value as C. So based on that, we are getting this addition operation. So this is how addition goes on in matrix. So logically, you have to implement. Logically, you need to implement this. So next in subtraction, it is the same this thing. Instead of plus, what you will be doing is you'll be just using the subtraction. So you consider say 3 by 3 matrix in this case, which is an example. And what we do is for subtraction, we take element of A which is having row index as R and column index as C, and subtract it with the element of B which is having the same row index and column index. So A1 minus B1, that is first row, first column of A subtracted with first row, first column of B. So similarly, rest of the things again follow. So now next is multiplication. So this is one of the important aspect what you have to look out for when we are implementing. So the implementation of this will be straightforward. You have to consider element by element and same row, same column, and then you do the addition. So this will not create problems for us. But when you're dealing with this, you have to look into the logical aspect. So how do I consider this? So in this case, we have 3 rows and 3 columns. So this is also having how many rows? 3 rows and 3 columns. So as per multiplication rule, what happens if I'm performing A into B, that is matrix A multiplied with matrix B, number of columns in matrix A should be equal to number of rows in matrix B. If A is having C number of columns, then B should also have C number of rows over here. Okay. So this is the condition what you look out for. So at present we'll not be going into the condition aspect. So we'll assume that that condition is satisfied. So based on that, what is the multiplication operation which you will be performing? So in this case, what we do, we multiply when we are multiplying. That is when we are taking A into B, right? So A1 is multiplied with first element of B, then that result, that is A1 into B1. So this result has to be added with the next product. So what is the next product, how it is taken? So here if I specify the index, this is having index 0, index 1, index 2, and this is having index 0, index 1, index 2. So these are the indexes pertaining to the rows and columns. So this is row index, this is column index. So similarly, I have 0, 1 and 2 over here, which is row index of this. And similarly here I have 0, 1, 2, which is the column index. So now you need to analyze this row and column index. So now first what we did, we considered A1 multiplied with B1. So we got this multiplication result. So this result has to be added with what? Element which is having index 0 and column 1. So matrix A's column has to be incremented. Column has to be incremented. And with which this thing we need to multiply? We need to multiply this with B4. B4, which is having what? Row 1 and column 0. Row 1, column 0. So similarly, what you do, you continue with the rest. So in this case, A3 is multiplied with B7 and added to the previous result. So this will give you the first element of AB. So it will be like AB of 0, 0. This is the first element, which is having index 0, 0. So next element, what you do? Next element, when you want, you multiply A1 with B2, A2 with B5, and A3 with B8. Now here, if you just make an observation, so the first row elements, what you have of the multiplication. So in this row elements are considered. One column, say 0th column is multiplied, you get the first element. Then you increment the column and you multiply with these elements, you get the second element. Then you consider 0th row and multiply with these elements, you get the third element in that row. So after this operation is performed, you increment the row which is pertaining to A in this case, and then you repeat the process. So this is the logical aspect what you are looking out for in multiplication. In multiplication. So it is all based on the indexes, how you are using it. So this again we'll look through a program over there. So now next we have the transpose. It is nothing but you interchange the rows and columns of the matrix, whatever is given to you. So here we can observe what we have. We have a matrix which is given over here. Here you can see that A1, A4 and A7 belong to 0th column. So this one will be converted to row in the transpose. This becomes the 0th row. This is the first this thing. So this is converted to the row, that is here it is column 1, here it will be the row 1 elements. So similarly the last one, that is column 2, it will be a row 2. You are interchanging the rows and columns of the matrix in a transpose. So now let us have a look at the program which is associated with these three things. So I'll not go for the addition aspects. What we'll do is we'll go for addition and subtraction, we'll go for multiplication, because it is straightforward over here. So here we can just observe what they have done. So up to this point, they are receiving the data from the user. They are accepting the data from the user. They have declared three matrices A, B, and C. And they are asking the user to enter the elements which are pertaining to A and elements which are pertaining to B. So once they are being entered, they are just printing it in the next this thing. So in this for loop, they are printing the elements of A and B. Now this is the major part what we have to look out for. So in addition, this is the logical implementation in terms of program. So you have to traverse element by element. You have to traverse element by you have to traverse element by element and try to see what is the overall result. So now what we have, for I is equal to 0, I less than 3, I plus plus. So if the condition is satisfied, you enter and traverse through the columns. So j is equal to 0, j less than 3, j plus plus. Next what you do is you perform a of I plus j, a of I comma j plus b of I comma j. So this is like what you're doing. You are performing a1 plus b1, then a2 plus say b2, a3, b3. So directly you are performing that operation in this case. That is what is happening over here. And you are storing the result in the same location. So here you can see. So if you are adding this element, so zeroth row, zeroth column, zeroth row, zeroth column element, you are getting the zeroth row and zeroth column element of the addition. So if you're adding any element, right, if you're adding say this A9 with B9, you will be getting this result. So what is the row number and column number of this? Row number as per the index, it is 2, 2. This one is also 2, 2, and the result also will be in 2, 2. So that is what is being considered over here. So this will be the logic. You traverse through each of the elements and add them. And what about subtraction? You just change this to minus. You'll be getting the result of subtraction. Okay. So this is the example pertaining to the subtraction aspect. Okay. Sorry, this is the multiplication, this thing, what we have to consider. So in this case, what we have again, we are accepting the two matrices and then we are printing those. And in this part, we are performing the multiplication. We are performing the multiplication. So I'll just traverse through the program and then we'll have a look of how it goes around. Yeah, this is the program. Okay. Okay, we have A, B, and another one is C. Okay, so let us have a look at this case. So we'll traverse through the data. So here we have A, B, C, which are the three matrices. So in which C will be storing the result of the multiplication. So now what we'll do is, so in this we are asking the user to enter the matrix A elements. So what we'll do is I'll be directly entering those elements. So it will be 1, 2, there's 1, 1, 1. Okay, so let us see whether it stores that information. Okay, so it has stored the information of 1, 1, 1 in the matrix A. Similarly, we'll try to enter the elements of matrix 2. Okay. Okay, so B is stored with element 2 in each of the rows and columns. So what we are doing is it is just displaying the elements which are present in both the matrices. Okay. So now what we do is we start off with the first that is the 0th row and 0th column, and then we continue with our estimation. So here what is done for I is equal to 0, for I less than 3. So initially I is equal to 0, 0 is less than 3, therefore loop is entered. So I is 0. So when loop is entered, j is initialized to 0 and the condition is satisfied, therefore it enters this loop. So j is equal to 0. And what you're doing is, since we don't know what values will be stored, so we are initializing c of I comma j equal to 0. So this step has been executed, therefore 0 is stored in 0th row, 0th column. So first what you're doing is you are first estimating 0th row, 0th column of the multiplication matrix, that is the matrix C. So for this purpose, as we specified, what we have to do is we have to traverse the first 0th row of A, and then we need to keep on incrementing with respect to one of the parameters. So we'll just try to see what is happening with the help of K. So here we can see that K is equal to 0. K is equal to 0. So what I'll do is I'll add a watch of K over here. So here we have I, J, and K. So these three things will just try to see what is happening. So now K will be initialized to 0 and the condition is satisfied. So therefore it enters the for loop. Now in this for loop, Cij initially before coming into this loop, it was made as 0 over here. So it will be 0, which is equal to 0 plus the product of this. So now what does this imply? Here you can observe what is I is 0. So if I read it in that form, it will be a of 0 comma 0, because I is 0 and k is 0. So I is giving you the row information of matrix A, and k is giving you the column information in this multiplication parameter. This element is multiplied with b of k comma j. So that is a of 0 comma 0 is multiplied with b of 0 comma 0. So, and that result will be stored in C of 0, 0. So still it is not over. We have to go for the next element and perform the next operation. We have to perform the next operation. So here what happens? So this you can we can observe what happens to the value over here depending on the parameter what we have. It is like a of 0, 0 is 1 and b of 0, 0 is 2. So 1 into 2, and this element initially it was 0. So it will be 0 plus 2. So 2 will be stored in C of 0, 0. But still the multiplication operation is not over. So it is like we have multiplied A1 into B1. Now we need to add this result. So now what we have got A1 into B1 in this one. This result we need to add with A2 into B4. A2 into B4. So what we performed first this. So zeroth row, zeroth column, zeroth row, zeroth column. Now what we have to do is we have to add A2 plus B4. What is A2 B4? It is zeroth row first column. So here you can see row is not changed for A. Row is not changed, but column has to be changed. And we need to multiply that one with B4. So this is having first row, zeroth column. So this is first row, zeroth column. So here you can see for B, this is not changed. And this result will be added to the previous case. So based on this, so what happens? C of I comma j, that is the second element what it had taken. So again, I'll just re-execute it because one step is missed out. Okay. So again, we start off with the first this thing. What we have, I is 0, j is 0, and here you can see that this element is 4. So I first need to clear it. So I have cleared it. Now what we do is we consider k is equal to 0 to traverse to change the row and column parameters of A and B. So that is what is done over here. So we saw that A1 multiplied with B1, 0th row, 0th column, multiplied with 0th row, 0th column. But next element when you went to multiply, it was A2 into B4. That is 0th row, first column, first row, 0th column. So it is based on that logic what you are implementing over here. So in the first iteration, what happens? A1 into B1 is multiplied. So and you get the result of 2. Now k is incremented to 1. So still I is 0, j is 0, now k is 1. So this is containing A1 into B1. We need to add it with A2 into B4 parameter, what we had discussed in the presentation. So that is given by what? A of 0, 1, because k is 1, 0, 1 multiplied with B of row 1, column 0, row 1, column 0. So that is like A2 multiplied with B4 and add it with the previous result. So that is what you're performing. So next again k gets incremented and the value is 4 over here. K gets incremented, condition is satisfied. So A1 into B1 plus A2 into B4. Now you have to perform multiplication of A3 into say B7 and add it to the previous result. So A3 B7 is given by what? A3 element is 0th row, second column, and B7 element is the second row and 0th column. So that will be performed and the result will be 6. It will be stored over here. Now what you are doing, you are still in the 0th row. I is still not incremented. Now J gets incremented. Now in this process, what happens? You are traversing to the next say column of matrix A. You are traversing to the next column of matrix A. Row of the previous this thing is still maintained. So here we can observe. So we are done with this part. So here 0th row, 0th column element of the multiplication result is obtained. Now what I want, 0th row, first column element. And if I want this, what I do, so still the row is 0 for matrix A. But what we do is we consider the column of this case. We multiply A1 B2 plus A2 B5 plus A3 B8. So the logic follows. So row of A which is identified by I, index I, is kept as it is, but only the column parameter is altered, which will be referred for B. So let us see what happens in this case. Okay. So what has happened? So here we can see I is 0, J is 1. I is 0, J is 1. So what if I just refer to this one, matrix A of 0. So you're still in the 0th row. But what about B? You have traversed to the next column. You have traversed to the next column. So we continue with this thing execution, and we see that multiplication happens in this form. So the same steps are repeated. So once 0th row elements of A are finished, you go and increment I and go for the next row multiplied with all the elements pertaining to B. So this action is performed. So this thing is performed, and you can see that the results are being stored in matrix C. And this is the printing part, what they are traversing through. So here we have two matrices, that is 1 1 1, in which A is having all the elements as 1, B is having all the elements as 2, and when you take the product of these two, you are getting the result as 6 6. That is all the elements are 6, since both the elements are same over there. So this is the logical aspect of how the program will go through when you are implementing multiplication. So this is all for this session, in which we discussed regarding what are the operations which we can perform on the array, that is transpose, multiplication, addition, and subtraction. So in that main concept, what we were looking for is the multiplication aspect. So this is all for this session. We'll be meeting in the coming fourth session with the next part, in which we'll be discussing regarding a linked list. Okay, thank you.